This is another installment of my experimenting with supercapacitors project. The last time we showed assembly of this card, which is a shield for this Arduino Uno, and this is a supercapacitance meter circuit, and it just plugs in to the Uno like this. Now that's just measuring capacitance. So this part of the project, we're going to do a functional test of this circuit, and I've written a little bit of code for the Arduino Uno to put it through its paces. So I have up here a liquid crystal display which is running through I²C, and I made a custom cable that just plugs into my shield like this. So now we have the shield on an Uno driving a display, and of course the capacitor under test is down here, and we can hook up some leads to the banana plugs, banana jacks, and we'll just connect up the capacitor. This is just a regular electrolytic capacitor, 4700 microfarads, because it will charge and discharge much quicker than the supercapacitors. So if we plug in power to the Uno and turn it on, oops, there we go. Hello, element 14 supercapacitor magic meter, and it's just doing some functional test of the RGB backlight. Now we have it displaying. In the first line we have the mode, which is the position of this switch. So right now it's the device under test and it's just showing voltage. And this is the voltage over here, 2.42 volts, measured at this capacitor terminals. And then on the bottom line we have the charge current and the discharge current. So I haven't got all these modes programmed yet, but we'll just run through they do have labels, so we'll run through that. So this first position is just measuring the voltage of whatever's on the capacitor, and ideally we would like to use this channel to measure the leakage over time. So this channel is measuring the lithium capacitors, and then this mode here is electrolytic double layer capacitors, supercapacitors. And then we have ESR, so that we can try and get the ESR of the capacitor. Those functions haven't been programmed yet, but what I wanted to prove is that we can charge and discharge the capacitor. So the final two positions on the switch, one is for charging and one is for discharging. And the first, it's set up to charge with about 137 milliamps, so that this this value here should briefly show 137 if it's, but it won't take long to charge up this capacitor. And then on the discharge position, it will discharge at something around 5 milliamps. This ESR position is actually set up right now to discharge at 100 milliamps or so. So let's just try that. So here we charge it up, and we just got a brief blip there, and it charges up to 2.5 volts. And if we discharge, we can watch the discharge current here, and we can see the voltage decreasing here. So it's going down to 1.9, 1.8 to 1.7, and it's discharging at 5.1 milliamps. And you can see the mode here is discharge. So that's discharged. If I charge it back up, to 2.52 again, and I discharge it on this ESR position, it will discharge quicker, and the discharge current should be about 100 milliamps, something like that. 101, and it just took a second or so to get down. So that's a functional test, and it means that we have control using the computer of the charge and discharge functions. And then to make this thing measure capacitance, all we have to do is set up some timing to measure how long it takes to charge and discharge to various voltages. So that's coming up in a future video, and we'll actually get into testing some supercapacitors as soon as I've put these functions for lithium capacitor and EDLC right here. So it's coming together, and progress. It's all functional. I did have some issues with this Uno. I was quite disappointed to discover that it connects the I2C lines, which are the two pins up at the top here, to two of the analog pins, which effectively eliminates two analog channels, leaving the Uno with only 3 analog inputs, because I'm using one for analog output. And that's kind of disappointing, considering it has all the capability of doing a lot more channels, and it's the highest resolution analog to digital converter in the Arduino lineup. It's got a 14-bit A to D, and they're kind of wasting it, but it does have enough channels to do what I need, and so we will be testing in the next video.